So right now, if you ask an artificial intelligence to generate a single high-definition video, it actually evaporates roughly the same amount of fresh water as taking 3 large water bottles and just pouring them directly out onto the pavement.
Oh, wow. Just right onto the concrete.
Right onto the concrete.
Yeah.
Gone. And I think we usually compartmentalize the world, right? Like, AI is just this invisible software floating up in the cloud. Energy is a utility bill. Logistics is, a delivery box on your porch.
Right. And cities are just the places where people happen to live.
Exactly. But for today's deep dive, our mission is to look at this massive stack of structural intelligence we have and uncover how all these seemingly separate layers, like AI, electricity, water, global logistics, and urban infrastructure, are actually aggressively colliding.
Yeah, they're merging into a single structural system now.
Yeah, they really are. And the core perspective we need to hold on to today is that the global operating system is abruptly reconnecting to physical reality.
It is a profound shift.
Yeah.
I mean, for decades, we sort of lived under this illusion that the digital world and the physical world ran on totally different tracks.
Right, like the internet was infinite, but the Earth had limits.
Exactly. And now we are watching that global operating system crash back into physical limits. And I will be focusing on what that actually means for cities, housing, water, and everyday human life, because the consequences are very real for people.
And I'll unpack the macro side. The massive systems, logistics, energy grids, and the sheer scale of this AI build-out. Because to understand this reconnection, we have to start with the biggest catalyst, which is artificial intelligence.
Yeah, the cloud is getting incredibly heavy.
It is. The first hurdle we have to get over is that AI is no longer a software industry, like at all. It has mutated into this massive, insatiable power grid load.
It's physical infrastructure now.
Completely physical. When you look at the data center power consumption in places like the UK and the US has hit roughly 6% of total electricity. And in some nations, it is rapidly approaching 10 to 19%.
Wait, 19%? Just for data centers?
19% of a nation's entire electrical output dedicated purely to maintaining a digital environment.
That is staggering.
Yeah.
It forces a complete rewrite of what we even consider infrastructure to be.
Right, because the cloud is actually a beast made of high-voltage transformers, cooling systems, generation capacity, and semiconductor supply chains.
Yeah.
When you ask an AI to train a new model, you are physically spinning up turbines.
You're burning fuel.
Yes, and more importantly, you are generating heat. These advanced GPUs run so incredibly hot that traditional air conditioning inside a server farm it cannot keep up at all.
Which brings us directly to the water issue.
Yeah.
Because to keep these localized clusters of AI chips from literally melting themselves into slag, the industry is shifting toward high-density liquid cooling.
Right.
And this isn't just a closed loop of water in pipes. A lot of these systems rely on evaporative cooling towers.
Like the water bottles on the pavement.
Exactly like that. They take clean, potable drinking water from municipal reservoirs, use it to absorb the massive heat from the processors, and then just evaporate that heated water straight into the atmosphere. That water is gone from the local watershed.
It's just wild. Let's put a sense of scale on that localized impact. Because our sources point to this massive Telus-linked data center cluster that's currently being built in Vancouver, Canada.
Yeah, that's a perfect example.
Projections show that to power and cool this single cluster, it could consume between 12 to 14% of the total power output from the massive Site C dam.
And we really need to pause and think about what the Site C dam actually is.
Right, it's not a small project.
No, it's a multi-billion-dollar generational hydroelectric project on the Peace River. It was designed to generate enough electricity to power roughly 450,000 homes.
450,000.
Yeah. So the idea that a single piece of corporate infrastructure, one data center cluster, is going to take a double-digit bite out of a region's primary energy and water resource, it fundamentally changes the local reality.
Wait, but I am struggling to square this. If an AI needs the water and power of basically a small town just to run its calculations in a place like British Columbia, what happens when it tries to move into a densely populated city?
Well, that is where things get really tense, because the presence of that machine fundamentally alters what makes a city valuable. We are looking at a total transformation of the city OS, the operating system of the city itself.
Thus so.
Historically, we valued a city by its GDP, right? Or its population size, or the financial district. But now urban value is shifting toward a city's compute hosting capacity,
Yeah.
its baseline electrical surplus, its cooling capability, and infrastructure resilience.
So it's shifting from housing people to hosting compute.
Exactly. The sources highlight Singapore as a really stark example of this. Singapore has always been, the quintessential global financial city.
Right, highly developed banking hub.
But they are aggressively pivoting into a compute resource city. Data centers there are consuming that astonishing 19% of the national power you mentioned earlier.
Wow.
But here's this. The friction water and cooling limits are now what restricts the city's growth. Their economic ceiling is literally dictated by thermodynamics now. They are running out of water to cool the servers.
And when a place like Singapore hits its physical limits, that tech build-out has to spill over somewhere else, right?
It does. It pushes right into neighboring regions.
Which perfectly explains what we are seeing in Kuala Lumpur, Malaysia. The reports detail how Kuala Lumpur is rapidly becoming this AI buffer city.
Right, buffer zone.
Yeah, companies like Equinix are pouring billions in there. And it's partly that physical spillover, but it is also geopolitical friction. Tech giants are trying to navigate these really tense U.S.-China semiconductor export restrictions.
They need neutral ground.
Exactly. But when you drop a multi-billion-dollar tech oasis into Malaysia, it collides directly with local power grid shortages and local water scarcity. So if a city's primary job becomes hosting compute instead of housing people, how does that tension play out for the residents, like the people who just want affordable electricity?
It creates intense political and social friction. Because on a macro level, governments want these data centers. It brings foreign investment, it looks great for geopolitical prestige.
Sure, it's a huge win on paper.
But on the local level, residents are facing the immediate fallout. If a massive data center gets guaranteed access to megawatts of power, the local grid strains, the cost to upgrade transformers to handle that load, that often gets passed right down to the local consumer's utility bill.
So a local family is basically in an invisible bidding war for electricity against a trillion-dollar AI company.
Yes. The basic necessities of daily life are competing directly with the cooling requirements of a large language model.
That is it's a massive systems clash. But to even build those compute cities, you need the physical hardware, right? And that brings us to logistics and raw materials. Because this AI race, it's sinking all the way down into the dirt.
It really is. It's not just floating software.
No, it's heavy earth mining. The bottleneck right now isn't just advanced GPUs in Silicon Valley, it's critical minerals, heavy rare earths like dysprosium, terbium, yttrium, and tungsten.
And why are those specific elements so crucial?
Because these chips run at blistering temperatures. The magnets used in their cooling systems and high-voltage power supplies, they degrade incredibly fast if you use standard materials. Dysprosium is injected into these magnets so they can retain their magnetic properties at extreme heat.
So without it, the cooling fails.
The cooling fails, the servers melt, and the AI goes offline. It is that foundational. And the extraction of those elements is, well, the supply chain is heavily influenced by Chinese export restrictions. So the new geopolitical center isn't just tech and cities, it's mining, power, and water.
And mining those heavy rare earths is a brutal, high-friction process for the earth. You're talking about pumping chemical solvents directly into the ground, creating toxic tailing ponds. The physical toll on the local environment is massive.
And once you extract it, you have to move it. Which brings up global shipping. For decades, global shipping was like a single, perfectly smooth superhighway. Everything was optimized, just-in-time delivery.
Highly efficient.
Highly efficient. But now, look at the disruptions in the Strait of Hormuz. That smooth superhighway is fracturing. But, and this is a key takeaway from the sources, the system isn't collapsing.
Right. Avoid the collapse narrative. It is just changing.
Exactly. It's adapting into what the reports call a high-friction but still flowing logistics model. It's like moving from fiber optic broadband back to dial-up internet.
Oh, I like that analogy.
Right. The container still gets from Shanghai to Rotterdam, but instead of one smooth trip, it gets unpacked, put on a smaller boat, moved onto a train, offloaded onto a truck. Every handoff burns extra time, extra fuel, and extra money.
And Iran is a really fascinating example of this dial-up logistics model in real life, because they are facing massive maritime bottlenecks and sanctions, but they aren't stopping trade. They are rapidly building out alternative distributed land networks.
Like using the Caspian Sea, right?
Yes, connecting the Caspian Sea routes directly into Central Asian rail lines to physically bypass the ocean choke points. They are abandoning the fragile ocean superhighway for this gritty, multi-route distributed land logistics system.
But everyday life continues,
Yeah.
right? It just gets harder.
Exactly. The system doesn't collapse. Your package still arrives. The grocery store has food. But everything is a little slower, more expensive, and a lot less stable. You're burning vastly more energy just to maintain the baseline.
Which leads me to a huge question. With all this friction accumulating, like more fuel burned, water tables dropping, grids straining, why aren't we seeing massive global systemic failure? Or even just massive public outrage?
That is a really crucial point. The intelligence stack identifies what it calls silent zones.
Silent so's.
Yeah. There are these strangely quiet areas right now. Local water politics, housing pressure, neighborhood electrical infrastructure, and the residents themselves. It's all relatively silent compared to the explosive growth happening above them.
But silence in a complex system isn't usually a good thing, is it? It doesn't mean stability.
No, it definitely doesn't mean stability. It's an illusion of capacity.
Right, I'd frame it as a phase mismatch. We have systems operating at completely incompatible speeds. The tech deployment and financial markets, they move at lightning speed. You can fund a server farm in weeks.
Yeah.
But the human layers, local politics, pouring concrete for a new power plant, laying transmission lines, that moves incredibly slowly. It takes years.
The velocity of software is literally slamming into the sluggish reality of physical infrastructure. A city council can't rezone land and upgrade transformers at the exponential rate an AI company scales its compute.
So the silence isn't a sign that everything is fine. It just means the friction heat hasn't sparked a fire yet.
Exactly that. The heat isn't accumulating inside the AI servers themselves. The real heat is accumulating in that speed gap between AI's explosive growth and the physical world's sluggish ability to accommodate it.
So since we are locked into this high-friction, asynchronous world where fast tech meets slow reality, what comes next? Because it clearly isn't about perfect optimization anymore.
No, the era of perfectly optimized global systems is over.
So it shifts to reconnectability. Future security relies on local logistics, distributed energy grids, small alternative ports. If a massive centralized grid fails, you need a neighborhood microgrid like solar or small-scale nuclear that can keep the lights on.
Right. Grounding that in everyday life, it means a resurgence of local repair networks. It means a city building community-level water cycles, so they aren't relying on one municipal pipe that an AI data center might suddenly drain.
It's about surviving the disconnection.
Exactly. Systems that can simply reconnect after a disruption are becoming far more valuable than systems that are highly efficient but totally fragile. We have to adapt our cities for resilience, not just output.
Wow. So the invisible cloud is gone, and we are back to heavy reality.
We really are. And perhaps what matters next is not perfect optimization, but whether systems still allow a way back after disconnection.